All right, today we are going to be looking at some more sections in Chapter 3. We're going to be looking at some types of triangles as well as angle theorems, first of all. So we can classify triangles in two ways. We can classify them by the lengths of their sides, and so it will fall into one of three categories: scalene, isosceles, or equilateral. If none of the two sides of the triangle have the same measure, meaning none of them are congruent, then you have a scalene triangle. If at least two of the sides are congruent to each other, then you have an isosceles triangle. And if all three sides are congruent, then you have what we call an equilateral triangle. So scalene, isosceles, equilateral has to do with the sides. For the angles, we just look at their measures. If all three angles in the triangle are acute, then it's an acute triangle. If one of the angles is obtuse, it's an obtuse triangle. If one of the angles is right, then it's a right triangle. And if all three angles are the same, it is equiangular. And a fun fact about equiangular triangles is they will also be equilateral and vice versa. If you have an equilateral triangle, it will be equiangular. So that is just how to classify them based on either the lengths of the sides or the measures of their angles. Now, speaking of the sides of a triangle, we have a rule for what the lengths of a side can be in order to make up a triangle. In order for them to form a triangle, the sum of the smaller two sides has to be greater than the third side. So we're going to practice that here first. I've given three numbers and I'm asked to decide, could these be the sides of a triangle or not? So looking at this first set, 5, 6, 8. My smaller two sides are 5 and 6. So in order for these to make up a triangle, 5 plus 6 needs to be bigger than 8. Well, 5 plus 6 is 11, and 11 is indeed greater than 8. So yes, the sides of a triangle could be measured 4, 6, 8, and that would be a scalene triangle because none of them are the same. 2, 3, 7. My two smaller sides are 2 and 3. So 2 plus 3 needs to be bigger than 7. 5 is not bigger than 7, so these could not be the sides of a triangle. On to the third one, 6 and 7 are my two smaller sides. That needs to be bigger than 13. 13 is not greater than 13. It's equal, so that also could not be the sides of a triangle. 4, 4, 6. 4 and 4 are my two smaller sides. And 8 is larger than 6, so yes, that could be a triangle. And if two of the sides are 4, that means that would be an isosceles triangle. Okay, lastly, 2, 2, and 2. They're all the same, but 4 is greater than 2, so yes, those could make up a triangle, and that would be an equilateral triangle. So that is your triangle side theorem and classifying triangles. We're going to move on to 3.7 now, and that's with our angle side theorems and relationships. So this pertains particularly to isosceles triangles. When I have two legs that are congruent, the angles that are opposite those legs are also congruent, and we call those the base angles. So terminology really quick. My two sides that are congruent we call our legs, and that third side is our base. So the two angles that are across from the congruent sides, those are my base angles, and so they're going to be congruent to each other, and then that third angle we call the vertex angle. So this relationship is true one of two ways. If I know that my sides are congruent, like if I'm told AB is congruent to AC, then I know that C is congruent to B. Angle C is congruent to angle B. Now, if you're told that the other way, for example, if you're told first that angle C and angle B are congruent, what that then tells you is the sides across from those two angles, AC and AB, are also going to be congruent. So we can use that to solve a variety of problems, and we're going to practice that next. Let's look at these four. We're finding the value of x in all of them. Looking at the first one. These tick marks here tell me that in this triangle, those two sides are congruent. So that means the base angles, this 48-degree angle and this angle here, are congruent. So if this angle is 48, the other one is also 48, and x is my vertex angle up here. Well, I know that the three angles have to add up to 180, so So x plus 48 plus 48 needs to be 180. So I'm going to solve this for x. 48 plus 48 is 96. So if I subtract 96 from both sides, I'm going to get that x is 84. That's the third angle. Moving on to number 2. Again, these two tick marks here tell me that those two sides of this triangle are congruent. So that means that my two base angles, the 75-degree angle and this angle labeled 2, are congruent. So that means that angle 2 is equal to 75 degrees. Well, if I'm given this expression for the measure of angle 2 being 83 plus x, that means 83 plus x is equal to 75. So what I need to solve for now is x. I'm going to subtract 83 on both sides. And I get that x is negative 8. Moving on to the last two. On 3, my tick marks tell me that these two base angles are congruent. So from that, I can conclude that the sides opposite them, the x and the 9, are congruent, meaning they have the same measure. So x is going to be 9 on number 3. On number 4, again, I've got these two tick marks telling me my base angles are congruent. So the sides opposite them are the 9 and the 2x minus 7. So those are also going to be congruent, and I can use this equation to solve for x. I'm going to add 7 and divide by 2 and find that x is 8. So with that, you now have enough knowledge to classify triangles based on their sides and their angles, and you have enough information to use the angle side relationship to solve problems, in addition to using the triangle inequality theorem to determine whether three sides can make up a triangle or not.